Hi students and friends, welcome to the channel Learn and Teach by Ayaz. So I will continue my video lesson for IGCSE 0620 past papers. And this time I have selected October-November 2022 and the paper is 42. In this paper, I am not going to talk about the instructions and information you have provided in this paper. I have already explained in my last video for October-November 2022 paper 41. So I will straight away continue with the paper. Question number 1. Diamond and graphite are different solid forms of carbon. The carbon atoms in diamond and graphite are arranged in different ways. A. State the number of covalent bonds each carbon atom has in diamond. I am drawing the structure of diamond. This is a small part of diamond. You see, each carbon is attached to 4 other carbon atoms. So you write 4 here. B. State the term used to describe the structure of diamond. It is giant covalent. C. Name an oxide that has a similar structure to diamond. Silicon dioxide. Silicon dioxide has structure similar to diamond. D. Describe the arrangement of atoms in graphite. The arrangement of atoms in graphite is layers and hexagonal rings. Hexagonal rings will be like this. And we have layers of these hexagonal rings. So you write layers, hexagonal, rings of carbon. E. Explain how graphite conducts electricity due to the presence of mobile electrons. So we write mobile electrons. F. Buckminster fullerene is a simple molecule form of carbon. The relative molecular mass of Buckminster fullerene is 720. Determine the number of carbon atoms in one molecule of Buckminster fullerene. It's very easy. The mass of one carbon is 12. So we want to calculate the mass of 720 carbon atoms. So it will be X, and X is equal to one carbon atom is 12 and X carbon atom will be 720. So we'll have 720 divided by 12. The answer will be 60. G. All forms of carbon burn to produce carbon dioxide. Name the substance used to test for carbon dioxide. It's lime water. So you write lime water. Number 2, sodium is a reactive metal. A suggests why sodium is stored under oil, so that the sodium will not come in contact with air, oxygen, and or water. To prevent sodium from coming in contact with air or oxygen or water. B. Sodium burns in air to form sodium oxide Na2O. Number one, state the term given to a reaction in which a substance burns. Combustion. Number two, state the color of the flame seen when sodium burns. This is something which you have to learn by heart. This is yellow. Number three, write a chemical equation for the reaction which takes place when sodium burns in air to form sodium oxide. So we know the symbol of sodium. This is sodium. The formula of oxygen will be O2. What will be the formula for the sodium oxide? Let's look at the periodic table. Here you will find sodium. This is sodium. And there is oxygen. Now predicting the formula between these two, Na, the valency of Na will be +1. Oxygen, it must be -2 because it is in group 6. Ignore their charges. Now these will become subscripts. And these subscripts will be exchanged. So you'll get Na2O. So the answer will be Na2O. Now let's balance this equation. In order to balance oxygen, we have to place 2 before Na2O. Na becomes 4, so we'll write 4 before Na. Now this equation is balanced. Number 4, complete the dot and cross diagram to show the electron arrangement and charges of the ions in sodium oxide. There are 2 sodium atoms. Each sodium atom has lost 1 electron, so they will definitely acquire +1 charge or plus charge. Now the proton number of sodium is 11. So there must be 11 minus 2, 9 more electrons. But this sodium atom has lost 1 electron, so we'll have sodium ion. So the number of electrons will be 8. We have to place 8 more electrons for this sodium atom. The second shell will have 8 more electrons. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, I'm showing the valence electrons for the second sodium atom. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen atom has gained or acquired 2 electrons, so it will carry -2 or 2 minus charge. Proton number of oxygen is 8. So after gaining 2 electrons, it will become 10, which means there are electrons, total number of electrons will be 10. 2 electrons are already shown. I'm going to show the 8 more electrons. I will use dot for sodium. 1, 2, 3, 4, 5, 6. These are the electrons of sodium. It has gained 1 electron each from the sodium atoms. So 1 and 2. See, sodium reacts vigorously with water to form aqueous sodium hydroxide, NaOH, which is a strong base. One, explain in terms of proton transfer what is meant by a base. Proton acceptor. Acid is a proton donor and base is a proton acceptor. Number 2, state the pH number that indicates the presence of a strong alkali. It must be 14. Number 3, state the color of methyl orange in aqueous sodium hydroxide. Again, you have to learn these things. So you write yellow here. Number 4, the equation for the reaction is shown. 2Na solid plus 2H2O liquid gives 2NaOH aqueous plus H2 gas. Calculate the concentration of NaOH aqueous formed in gram per decimeter cube when 0.345 gram of sodium is added to 50 centimeter cube of distilled water. Assume there is no change in volume. Use the following steps. Calculate the number of moles of Na added. The grams of sodium is provided. So in order to calculate the number of moles, we will divide these grams by the AR of sodium, which is 23. So when you divide 0.345 by 23, you will get 0.015. These will be the moles of sodium. Determine the number of moles of NaOH formed. This is a relationship between Na and NaOH. According to the equation, 2 moles gives 2 moles of NaOH. Therefore, 0.015 moles gives X moles. So it will be X is equal to 2 multiplied by 0.015 divided by 2. The answer will be 0.015 moles of sodium. Calculate the concentration of NaOH in mole per dm cube. The volume is given, that is 50 centimeter cube. So we will write 50 centimeter cube contains 0.015 moles. Therefore, 1000 centimeter cube contains X moles. So X will be equal to 0.015 multiplied by 1000 divided by 50. We will get 0.3 mole per dm cube. Determine the MR of NaOH and calculate the concentration of NaOH in gram per decimeter cube. In order to determine the MR of NaOH, the nucleon number of Na is 23, oxygen is 16, hydrogen is 1. So you will add these, then we'll get 40. So 40 will be the MR of NaOH. Now I want to calculate the concentration of NaOH in gram per decimeter cube. Moles of NaOH is there. So we will multiply 40 by 0.3. The answer will be 12 gram per decimeter cube. D. When NaOH aqueous is added to aqueous iron 3 chloride FeCl3 aqueous, a solid product is formed. Number 1, name the type of reaction where a solid is formed from 2 solutions. So precipitation. Number 2, state the color of this solid product. It contains Fe+3 and Fe+3 is red brown precipitate. So we write red brown. Number 3, name this solid product. The name will be iron 3 hydroxide. When you react NaOH plus FeCl3, you will get 2 products, NaCl plus FeOH both twice. The reason is that Fe carries +3 charge. We know the charge on OH is -1. Ignore their charges. These subscripts will be exchanged. So you will get FeOH whole thrice, which is iron 3 hydroxide. Number 4, write the ionic equation for the reaction. Include state symbols. The equation will be this: NaOH aqueous plus FeCl3 aqueous gives NaCl again aqueous plus FeOH whole thrice solid. This is the solid product produced. First, balance the equation. In order to balance OH negative, we have to put 3 before NaOH and also 3 before NaCl. The equation is balanced. Now cancel out the common or spectator ions. These are the spectator ions or common ions on both sides of the equation. So we are left with 3OH minus aqueous plus Fe+3 aqueous gives FeOH whole thrice solid. Number 3, sulfuric acid is manufactured by an industrial process. Sulfur is obtained from sulfur-containing metal ores. The sulfur in the metal ore is converted to sulfur dioxide, which is then oxidized to sulfur trioxide as shown. 2SO2 gas plus O2 gas gives 2SO3 gas. A. Name a metal ore which contains sulfur. It's a zinc blende. B. Describe the process which converts metal ores to sulfur dioxide. So we'll roast this ore in air or strongly heat. Roast or strongly heat the ore in air. C. Name the industrial process used to manufacture sulfuric acid. It is contact process, so I'll write contact process. D. The reaction that produces sulfur trioxide is an equilibrium. The forward reaction is exothermic. State the temperature and pressure used to make sulfur trioxide. Temperature will be 450 degrees centigrade and pressure will be 122 atm. Number 2, name the catalyst used. Catalyst is vanadium 5 oxide. Number 3, describe two features of an equilibrium. Rate of forward reaction equals the rate of backward or reverse reaction, and the concentration of reactants and products no longer change. Rate of forward reaction equals the rate of backward or reverse reaction. Concentration of reactants and products are constant or no longer changing. Number 4, state the effect, if any, on the position of equilibrium when the following changes are made. Explain your answers. Temperature is increased. Now, if you increase the temperature, the equilibrium will shift towards the left-hand side because forward is exothermic or backward is endothermic. Equilibrium shifts toward reactant or left-hand side because forward is endothermic or backward is endothermic. Now, what will be the effect of increasing the pressure? For this, you should know the number of moles on each side of the reaction. The number of moles on each side of the reaction will be, we have SO2 gas plus O2 gas. SO3 will be the product. It's also gas. Now count the number of moles on each side. On the reactant side, 2 plus 1, 3, and the product side on 2. So if you increase the pressure, the equilibrium shift towards the side with less number of moles. Equilibrium shifts toward product or right hand side because less number of moles on product side or higher number of moles on reactant side. Number 5, explain in terms of particles what happens to the rate of reaction when the temperature is increased. This is very easy. Rate increases because particles have more energy. Particles have more energy. More collisions occur per second. More collisions between particles occur or take place per second. High number of particles have energy equal to or above the activation energy. Higher number of particles have energy equal to or above activation energy. Name the compound formed when sulfuric acid reacts with ammonia. When mineral acids react with ammonia, they form ammonium salts. So when ammonia plus mineral acid, we get ammonium salt. The name of the salt depends on the negative ion in the mineral acid. For example, if you have HCl, you will get ammonium chloride. If you have H2SO4, which is sulfuric acid, you will get ammonium sulfate, etc. So you'll have ammonium sulfate here. Number 4, a student prepares magnesium sulfate crystals, MgSO4, by adding excess magnesium to dilute sulfuric acid. A, write the chemical equation for this reaction. It's reaction between magnesium, Mg, plus sulfuric acid, plus H2SO4. The salt will be sulfate of magnesium. Let's predict the formula between magnesium and sulfate ion. Magnesium belongs to group 2, so it will carry +2 charge. Sulfate carries -2 charge. Ignoring their charges, the numbers will become 2 and 2. Both are same numbers, so ratio will become 1, 1. So these subscript will be exchanged. So the final formula will be MgSO4. The other product will be hydrogen gas, H2. B, describe 2 observations which show the reaction has finished. Solid stops dissolving. Solid stops dissolving. And you have no more fizzing, which is due to the formation of hydrogen gas. C, the excess magnesium is removed by filtration. State the general name given to a solid separated from a solution by filtration. We call it residue. D, the aqueous magnesium sulfate is heated until crystals begin to appear. 1, suggest the name for a solution in which no more solute can dissolve. We call it saturated solution. 2, suggest why more crystals of magnesium sulfate appear on cooling. Solubility decreases as temperature decreases. Solubility decreases as temperature decreases. E. Magnesium sulfate crystals have the formula MgSO4.X2, where X is a whole number of molecules of water. The student heats the crystals to remove the molecules of water. MgSO4.XH2O gives MgSO4 plus XH2O. Name the term given to crystals containing molecules of water. Call it hydrated. Number 2, the student heats a sample of MgSO4.XH2O and finds it has lost 0.04 moles of H2O and has 2.40 gram of MgSO4 remaining. Determine the value of X. Use the following steps. Calculate the MR of MgSO4. Now I want to calculate the MR of MgSO4. MgSO4. For Mg, the nucleon number is 24. 24 plus sulfur. Sulfur is 32. 1 multiplied by 32 will be 32. For oxygen, it will be 16. 16 multiplied by 4 gives 64. So we'll get plus 64 here. So the MR will be 120. So you write 120 here. Determine the number of moles of MgSO4 formed. In order to find the moles of MgSO4, what we will do? We will divide the mass of MgSO4 by 120. 2.40 divided by 120. And we will get 2.4 divided by 120. 0.02 moles of magnesium sulfate. Determine the value of X in MgSO4 dot XH2O. Now, according to the formula and the data given, we know that 1 mole contains or produces 0.140 moles. It has lost 0.140 moles of H2O. 0.1040 moles of H2O. Moles MgSO4 dot XH2O. 1 mole lost this. So 0.02 moles lost X moles. So cross it, we'll get X equal to 0.140. Sorry, 0.02 moles. 0.02 moles has lost 0.140 moles. 1 mole has lost X moles. So it will become 0.140 divided by 0.02. The answer will be 7. F. If the student uses dilute nitric acid instead of dilute sulfuric acid, the salt formed is magnesium nitrate MgNO3 twice. Write the chemical equation for the reaction when solid magnesium nitrate is heated. When you heat magnesium nitrate, you will get 3 products. One will be magnesium oxide, MgO. The other will be nitrogen dioxide, NO2. And the third one will be oxygen gas. Let's balance these. So we will have 1 atom of magnesium on both sides of the equation. So it is balanced. What about nitrogen? On the reactant side, it's 2, but on the product side, it is 1. So it is not balanced. So I'm balancing this equation. Gives MgO plus 2NO2 plus O2. What about oxygen? 2 multiplied by 3 is 6. On the product side, there are 5 oxygen atoms. So if I will place 2 before MgO, then the number of moles will be of oxygen. Sorry, on the product side, there are 2 multiplied by 2, 4, 4 plus 2, 6, and 6 plus 1 is 7. So we have 7 moles on the product side. So you have to place 2 before MgNO3 whole twice. Now, in order to balance magnesium, I have to place 2 before MgO. What about NO2? I have to put 4 instead of 2. Now nitrogen is balanced. Let's count the oxygen atom now. 2 plus 4 2s are 8 plus 2. It will be 12. And here 6 multiplied by 2 will be 12. So oxygen is now balanced. So this will be final balanced equation here. Number 5, ethane is an alkane which undergoes a photochemical reaction with chlorine as shown. C2H6 gas plus Cl2 gas gives C2H5Cl liquid plus HCl gas. A, write the general formula of alkanes. This is which you have to learn by heart. CnH2n plus 2. B, state why this reaction is described as photochemical reaction. It needs ultraviolet light, UV light. C, in this reaction, an atom of hydrogen is replaced with a chlorine atom. State the name of this type of organic reaction. These type of reactions are known as substitution reaction. So I will write substitution. Part D. In this reaction, one of the products is chloroethane. Name the other product. The other product is hydrogen chloride. Part E, the energy profile diagram of this reaction is shown. This is the energy profile diagram. On x-axis, you have progress of reaction. On y-axis, you have energy. These are the reactants, C2H6Cl2 plus Cl2, and the product will be C2H5Cl plus HCl. Number 1, name the energy change labeled A. This is activation energy. So I will write activation energy. Number 2, name the energy change labeled B. This is B is enthalpy or heat change. Enthalpy or heat change. Number 3, state how the energy profile diagram shows this is an exothermic reaction. The energy of product is lower than the reactant. Energy of the product is lower than the reactants. F, the equation for the reaction can be represented as shown. This is a reaction. We have some bond energies also given in the table. Use the bond energies in the table to calculate the energy change in this reaction. This is the reaction taking place, CC. For breaking of bond plus Cl. Calculate the energy needed to break bond. So first of all, we will add up all the energy required for breaking the bond. We have 6 CH bonds, 1, 2, 3, 4, 5, 6. 6 CH bonds. So we will multiply 6 by 410. And we have 1 Cl bond. So we have 240. We will add 240 to this. What you will get? 6 multiplied by 410 plus 240 will be 2000 6 multiplied by 410. 2460. And we have 1 Cl bond. So we have 2460 plus 240. $700. And we also have CC bond. So we'll add 1 CC bond here, also 350. So add 350, we will get 3500 kilojoule. So this is the energy required to break the bond. Calculate the energy release in making bonds. So what bonds are made? So I'll draw the products here. I'll show you the product. These are the products. So you can now write down the formula for the products. This time we have 1, 2, 3, 4, 5 CH bonds. 5 CH bonds and 1 CC bond, 1 CCl bond, and 1 HCl bond. So we will multiply by 4 by 410. 5 by 410. 1 CC bond will be 350. And 1 CCl will be 340. And 1 HCl will be 430. So if you add up these, you will get 3170. Now the final, determine the energy change in this reaction. So what we will do, we will subtract 3050 from 3170. The answer will be 120 kilojoule minus 120, because 3050 minus 3170. A carboxylic acid, number 6, a carboxylic acid Y has a structure shown. This is a carboxylic acid. A, state the general formula of carboxylic acid. CnH2n plus 1 COOH. B, name carboxylic acid. Then there are 1 carbon atom, so we'll write methanoic acid. C, write the molecular formula of carboxylic acid. There are 1 carbon atom, 2 hydrogen atom, and 2 oxygen atoms. CH2O2. D, complete the dot and cross diagrams to show the arrangement of electrons in a molecule of carboxylic acid Y. So first of all, we'll show the electrons for oxygen atom. Each oxygen atom must have 6 valence electrons. So we'll have 2 electrons will be shared with this carbon atom. 1, 2, 3, 4, 5, 6. For this oxygen atom, 1 will be shared with hydrogen atom, 1, and 1 will be shared with the carbon atom. Now it's left with 4 electrons. 1, 2, 3, 4. For each hydrogen atom, I am showing their valence electrons, which are 1. For these, carbon atom must have 4 valence electrons. 1, 2, 3, 4. This will be the final dot and cross diagram. E, carboxylic acid Y will react with propane 1-ol C3H7OH to form ester Z and 1 other product. Name and draw the structure of ester Z. Show all of the atoms and all of the bonds. The name will be, the alkyl group will come from alcohol, and here the alcohol is propane 1-ol, so you write propyl. The carboxylic acid is methanoic acid, so you'll have propyl methanoate. So for propyl, I'm showing 3 carbon atom, 1, 2, 3, and now it's attaching with through oxygen atom with the carboxyl group of methanoid. This will be methanoid. Now I'm showing all the hydrogen atoms. Number 2, name the other product formed when carboxylic acid Y reacts with propane 1-on. The other product in this reaction will be water. Number 3, name an ester which is a structural isomer of ester Z. Structural isomer of ester Z. You want to draw or name another isomer of this ester, which is also ester. So you have 4 carbon atoms in total. So you can write any one of these. Any one of these. You can have a propyl methanoid. You can have methyl propanoid, or you can even write ethyl ethanoid. A carboxylic acid, which is a structural isomer of ester Z. Carboxylic acid. So the carboxylic acid must be of 4 carbon atom. So it will be butanoic acid. Thanks for watching. Press like and share my videos. Give comments. For more videos, subscribe to my channel and press the bell icon.